Hello, I'm Dr. Papia Bhattacharjee. So in the past few videos, we have been analyzing this function y equals x over natural log of x. Recall that we have gathered all this information about this function. And now we would like to graph this function on the xy coordinate plane. So let's see, let's start with the asymptotes first. It's better to draw the asymptote. We know that there are no horizontal asymptotes, but there is a vertical asymptote at x equals 1. So why don't we start with that? So at x equals 1, we will have a vertical asymptote. All right. Now, we know the function behaves this way around x equals 1, and we will plot that soon. But we also need to see if there are any points on the graph of the function that we know of. Now, notice that the relative extrema is at x equals e, and that's a minimum point. So, say if this is 1, and x equals e is about 2.7, so the function will have a relative min at that point. It's better to find the y value as well, so we know what the exact point will be on the graph. So what is y equals? So just plug in x equals e in the function, you get e over natural log of e is just 1. So y is e as well. So let's see, say about 2.7 and a 2.7 up here. So about this point will be a relative min, and the function, that means it's a point on the graph of this function. Okay, let's see. From the right side, as x is approaching 1, the function is approaching to positive infinity. So the function will be approaching to positive infinity right here. Okay. Now what is happening to the right side? So the function is going this way, pass through the infima, the minima I mean, and then what happens? Then as x goes to infinity, the function is going to go towards infinity. But in the middle, there is an inflection point. So there are lots of information. So let's plot these points first. This is a point on the graph. Now inflection point will be another point on the graph. Let's figure out the y value for this one as well. So y will be e square over natural log of e square, which is a 2 by using the property. So the inflection point is when x is e square and y is e square over 2. Now e square is about 7. And e square over 2 will be about 3.5. So the point will be, here is 3, so here is 4. So the point will be about here. Okay, now let's try to plot this first. The function is coming down because it has a minima, right? Notice that to the left side of e square is concave up. So it'll keep going to this inflection point. It's concave up. After e square, it's concave down, but it's going to keep increasing. So concave down, so change concavity, but it'll keep increasing. So that's this side of the graph. Now what about the left side of this vertical asymptote? So we know that when x is approaching 1 from left, function is approaching to negative infinity. So it'll be going towards negative infinity. So that we know. Then what? What happens? Is there anything else on this side? Okay, we know that the function is not defined as at x equals 0. We know that. So there will be a a hole right here. And then how do we join this portion? So let's compute one last limit. And that limit that we want to figure out is what is happening to this function as x is approaching towards that hole, 0. So x is approaching to 0, but only one-sided, right? Just the right-sided. What is happening? Okay, so just notice each of these expressions separately. As x is approaching to 0, the numerator is going to 0, of course. So I should not say equal sign. It's like it's approaching to. Okay, the numerator is going to 0. What about the denominator? What happens to natural log of x as x approaches to 0? Natural log is approaching to negative infinity. You recall the graph of natural log. And so 0 over infinity, 1 over infinity is 0. So this is actually approaching to 0. So that means as x is approaching to 0, the function is approaching to 0 as well. But it will never reach because the function is not defined there. And so we just join this part. So that's how the function behaves. It's going towards negative infinity here. It's going towards infinity, but concave down, has a minima, and it has an inflection point. That's a rough sketch of the function y equals x over natural log of x. That solves this entire problem. Thank you.